Well, hello and welcome again. It's been a little while since I've done one of these, so it's definitely worth updating. So this is what we have so far. This is our model viewer. As you can see, we brought in some colors to our grid. We have a grid, and if you get real close there, we kept our little reference coordinate system. A couple things I definitely need to change is changing the XYZ orientation. Right now it's kind of in the perspective of a graphics library where you think Z is kind of into the page. When it comes to groundwater models and kind of any kind of physical model, Z is usually kind of up and down. So that's definitely something I want to fix. Each of these grid cells here, the idea being that it kind of represents a pressure, if you could think of it that way, or if you want, you could think of it as like a heat. So all it is just like a scalar value associated with each of these grid cells. I just want to quickly show you what that looks like. So one of the big things was for the code to be able to read what would be a MODFLOW file. In this case, we have our number of X grid cells, number of Y grid cells. Again, that's kind of going to be up and down as opposed to into the page. And then Z would be into the page. Our grid width is 1 meter by 1 meter by 1 meter, so perfect cubes. And then we have kind of the head field. So the idea is like kind of from left to right, you go from high pressure to low pressure. So yeah, that's where we're at right now. It was kind of a headache to update to read a MODFLOW file. There's actually a few abstractions that kind of go in here now, which I'll just talk you through in this little slideshow. I wonder if that works. Or maybe not. Let's see. The thing is, I was so keen on just slideshow, Control F5. All right. I was just so keen on doing this all in one go. I'm probably still going to do that. Okay, so an overview. The whole project, we're creating something called GroundwaterViz, and the idea is we just want to load MODFLOW 6 files, convert them to a 3D geometry, and then visualize the data. So right now, the idea was I just kind of made up some synthetic stuff, like 100 to 10 isn't really realistic values, but if we had like even just properties like material properties like hydraulic conductivity. If you have no idea what I'm talking about, that's all good. I'll make a separate video later to kind of describe that. The tools that we're using is the Qt framework. That's kind of doing all the heavy lifting for us. C++ 17, that's kind of what I'm hoping to get better at, is just 17. I know we're at 26 as of making this video, but yeah, I'm not a professional programmer. I'm just trying to get the basics down. Having a hard time, and I think 17 is kind of a good middle ground of what's modern and what's kind of well documented. Then we have OpenGL, of course, our graphics library. So the idea is we kind of take our C++ instructions, convert them into OpenGL instructions, and that's what the graphics card actually takes in to kind of show the visualization. Our build system is CMake, and right now I'm using GCC. If you haven't been able to tell, I'm actually on a Linux machine, so GCC kind of is a natural fit. The overall project structure, so again, called GroundwaterViz. We have our core library, our I/O library, rendering library, and UI, and then finally assets. So I'll just hop through here. So core, this is kind of the simulation and data layer. We have a class called grid3D, and the idea is that this thing kind of handles the actual grid dimensions. So it converts the MODFLOW file into like grid dimensions, grid size, and then the scalar data. So that was kind of the biggest change from the last video. The text file parsing is handled in the I/O layer, so the idea is that we're going to have a MODFLOW reader class that parses dimensions, cell size, scalars, and passes this to the grid3D class. And then rendering, so that happens in the rendering directory. We have OpenGL rendering. There's a camera class that handles projections, view, and model, kind of that, P times V times M coordinate space to kind of get it plotting on your screen. We have something 3D and you want to project it onto something flat. That's kind of what happens here. We have iRenderer, which is the abstract interface class. So this is kind of where we had the factory pattern. If you don't know what I'm talking about, this is more for me to remember. But the idea is you have a class that kind of is super, super high level, and then it kind of is like the skeleton of other classes that come after it. We have a grid mesh class. This kind of handles the data from the Grid 3D class that I talked about earlier, and this is for rendering, so you could think of this as kind of the middleman between the core layer and the renderer. And then finally the filled grid renderer, which actually does makes the image. Another thing you probably saw was the reference grid that we had on the floor there, so the grid line renderer, and all this is just like simple cubed, or simple like almost like Outrun style, the game Outrun flat surface in our little model space. The UI layer, which I've yet to really do too much with, is where the Qt widgets are going to live. So if you're familiar with the Qt framework, all it is kind of like a GUI, graphical user interface framework that's really popular for C++. And the idea is like you have a bunch of widgets, you kind of drag and drop stuff onto like a screen, and you could have like little buttons to press. Actually, I'm just going to go back. And in that, we have the viewport widget, so that's actually kind of the window that shows up and, orchestrates kind of the rendering. And it owns not only the renderers, but the camera class, which is so important. So some steps in no particular order. I wasn't too happy kind of going through a text file and kind of plotting up random colors to show up on the screen. So what I'm thinking to do is to do a little mini MODFLOW class that's going to live in the core layer. And the idea is we kind of write out like a really simple bare bones model and modeling results that kind of write data for reading. So that'll be a lot better than me just writing in junk numbers to show up on the screen. And I'm hoping it'll be better in terms of testing and stuff like that. And with that MODFLOW class, I can kind of introduce what I'm actually doing here, like kind of relevant to my day job, is doing a lot of MODFLOW modeling. So if I could kind of explain maybe the basics of hydrogeology and hydrogeologic modeling, maybe the rest of the project can make sense. After that, improve scalar rendering. Kind of related to that first one, this thing called hydraulic conductivity, and you could think of it as kind of like the geologic material type. You got a sandy thing, or you have maybe like a rocky thing, and each of these would have like a different conductivity, and that's like how permissive it is to flow. Color maps, right? Right now we're just going from blue to red. Might be cool to have different color maps, and right now min-max scaling with the color map isn't really there. Right now it kind of assumes that 1 is the hottest and 0 is the coldest kind of thing. Another thing is that we're reading just a dummy text file, so the hope is to kind of upgrade our Grid 3D class to read actual MODFLOW files. Another thing that's so important is slicing of the model, right? You just kind of have something in 3D, we're just flying around, but sometimes you want to cut into things that matter, and our model does not do that yet, or our code doesn't do that yet. The last little step is to actually use the Qt framework to make more widgets. The idea is to have buttons that we can click through and select things. Something kind of almost commercial, professionally built, I would say. I'm just going to hop back to this thing again, kind of show you what I'm talking about, right? So this is the model, right, from cold to hot, and then we have our little flat 3D space. The idea is we could fly around, and the interesting thing about this is not actually just rendered on the core of your computer. This one actually talks to my GPU. So to test that, before I close off this video, I'm just going to go into my text file here, and I'm going to just make it like 1,000 by 1,000. I hope this doesn't just crash the computer, but I just want to show kind of what it's capable of. I'm going to close that again, and we're going to hit run on the Qt creator. Just building. Look, it's loaded 1,000 by 3 by 1,000 grid. It's running. Boom. Okay, and I just want to show you the scale of this thing, right? So this is totally awesome, because despite being written by an idiot like me, we can kind of we have this giant grid that actually plots, that actually works. So yeah, pretty happy with it so far. Definitely a lot more to do. As you can tell, it's not smart enough to know. It's not smart enough to know when the data exceeds the grid, or when the grid size exceeds what data it has. So it kind of just repeats the pattern at the bottom here. So definitely something to work on, but yeah, pretty big. And if you could think of it like compared to our reference grid, you're like way bigger, right? So I don't know, maybe I'll just try to fly all the way over there. Yeah, another thing I could do is kind of zoom in, but just keep going, keep going, keep going. Pretty cool, right? It kind of updates the projection. All right, so I'll link to the code is in the description. You're welcome to check it out. I'm open to any kind of feedback, criticism even, if you have any. And until next time, I'm definitely going to be trying to post more videos. More for my own accountability is I just want to get a little bit better at C++, and if I can also get better at my day job too, that'd be great. But yeah, thank you so much for checking out the project, and hope you have a great day.